Okay, so guess I'll share in a second here. Just a little description of what I'm going to show is some history of the LENR low energy nuclear reaction research. That's the name of how cold fusion is currently accepted within the academic field, as well as structural lattice fusion, which NASA now has stated they have evidence of. And it has to do with the crystallization of matter and through the electrolysis process of very low energy and input into the reactions, and then through the salt and energy input into the reaction, these small fusion reactions are able to happen from it and within it. And it seems to actually connect into the ancient alchemy science a lot more than what's been led to believe. And myself going through Sir Isaac Newton's alchemy writings that have been finally translated and made public, I've reproduced a lot of his descriptions of the transmutations of elements. And it seems that there's a whole lost science, higher science of this LENR sort of reactions and processes. But to start it off, I'm going to play a clip of a YouTube channel of a garage scientist just demonstrating a helium cold fusion reaction within an electrolysis setup. And the key part is that there's a plasma arc between the anode and cathodes in the reaction when it happens, and it's within this energy arc, the plasma arc, that higher levels of transmutations of elements and fusion are able to happen within these LENR sort of reactions. And please let me know if the sound works.
Today we're going to make something truly special. We're going to make something called cold.
An echo.
The loading ratio is like 90.
You got like an echo, and then the sound stopped working, Bernard.
LENR stuff.
Okay, hold on one sec. I'll try to
experiment.
Lattice fusion.
Try to figure that out.
Lattice system reactions. It's the hydroton model that Storms came up with, and it's based on entanglement. They say that what happens is you get all these deuterium atoms packed in this lattice tight enough that they start to entangle your entanglement states, and then that's what you can trick that cool barrier instead of
Just tell us through.
Sorry.
yeah, you just tunnel through it. So
Let's see if
because the Hamiltonian, so that's
this works better.
kind of set up. This is Hamiltonian.
So, okay, why the
chain of
office here
reaction.
is taking a little break.
So we're going to do
Want to reconnect with you like all this.
things are going to go on.
Sorry.
Let me show you.
Weird.
That you can actually get these things that are great
Sorry about this.
barrier form in terms of potential. So
There we go.
yeah, they use play cathodes.
Come on.
All right, here's the heart of our machine. We have two rods of tungsten carbide, one uninsulated, holding some stainless perf, one insulated with plastic coating, and these little porcelain insulators, you may recognize them, they are fuses. I took the end caps off, hollowed them out, slid them over our tungsten carbide rod for a little heat protection. I don't know if it's going to do much, but we have to do what we can because the process inside here is going to be very, very violent and hot. Now, you can see this is just the top of the water filter. Here we're going to have our thermometer, our negative and positive connections. Yes, they're just tubes, but they are connections.
The same Dutch guy that.
Now, let's put this puppy together. Okay, now we're going to put some water in our little tank. Yes, you guessed it, it's going to be distilled water, not tap water, not spring water. It has to be distilled. So we're going to pour that in. Okay, we don't want to fill it up all the way, just halfway would be fine. And we're going to put our anode and cathode array back inside. And that's basically how it sits. Now, we still have to put in our electrolyte, which is KOH. But first, I'm going to talk about the process a little more. Now, what happens in this chamber, it's going to make a plasma arc. It's also going to make hydrogen. What's going to happen when the plasma arc hits the hydrogen? You guessed it. It's going to burn the hydrogen. That's how this process works. The plasma arc and the current make hydrogen and burn hydrogen at the same time. That's why some people say that we can make over unity by using a little energy to excite the hydrogen to make more energy. This is what the big controversy is all about. I don't really care about the controversy. I just care that there is a process going on here and we're going to get to experience it. Okay. Now we're going to add some KOH. Again, nasty stuff. We're going to put on some safety gear. My trusty yellow glasses and some nice gloves. Again, I cannot stress safety. KOH, again, was used for drain cleaner. It's nasty stuff. You do not want it on your skin, and especially you do not want it in your eyes. So we have to be very careful with this stuff, okay? All right, we're going to start adding the KOH. Now I'm going to put in a little at a time so we don't put in too much. Again, if we get too much current flowing, the experiment's not going to work. If we don't get enough current flowing, the experiment's not going to work. So what we're going to do is we're going to put in a little right now, and we're going to close it up, and then we're going to play with it. We're going to find out at what point we have the right current flow. Yeah, it's a little experimental, but, you know, that's science. So we're going to put in a little more. And now we're going to screw it together. And we're going to put it back into our stand. Okay. Okay. So we have our transformer hooked up. We have our canister in place. We have our anode and cathode and our negative and positive hooked up. And also here, this little stainless tube is a thermometer, which is hooked up here so we can monitor our temperature. This is where the experiment's going to happen, is the temperature. Now, let's fire it up. Now we've plugged in our variac. Oops, I forgot to tell you what a variac is. This is a really big volume control, like on your stereo, except it controls current in volts. It regulates how much current flows through it. Like, let's say we wanted to limit the current that goes to our transformer. Well, we only turn the variac up to 10%. Now, as you can see on our gauges already, we're registering some current and some voltage. Now, we have to warm this up slowly. You can also see that we're bubbling here inside the reaction chamber. That is hydrogen being made. Now, because it's high current and not low current, we have less volume of hydrogen, but more current through the water, which heats up the water. If you watch closely, you'll see this thermometer click up, and it'll heat the water slowly. And we have to heat the water slowly for the next 10 or 15 minutes till we get it to 100 degrees before we can kick on full volume. If I was to turn on the power full right now with the variac, you'd see the reaction, but only for a short bit. It would pop the breaker either on the variac or the transformer or the breaker on the cell. One of them would go. That's why we have to heat the water to the right temperature to give it the right resistance to make this experiment work. So, we're making a little hydrogen. We're up to temperature. As you notice, our voltage is relatively low, our amperage is dropped down. Now I'm going to go ahead and give it some more power. You can see on our what's up meter, we're using 92 to 94 watts of power. But I'm going to turn it up. So now we're using a little more power. Our amperage is 2.5. Our volts is at 50. We're bubbling down there, nothing special. Now, we are at 107 degrees. Now we're going to let her have it. There's our reaction. As you can notice, we're at 250 volts.
So I'm just pausing it here to add in and notice and state that it's this plasma arc, but like so the arc between the anode and cathode there that creates the plasma, and within that plasma, this fourth state of high energy molecules all. And like, look right here, little reactor already working, proving it. Let's test it. Give me money, government or private angel investor. It's so frustrating. Anywho, enough of my rant. Let's continue.
Amperage is going anywhere from 3 to 2. And that's the fusion process that supposedly is impossible. It's 182 Fahrenheit. That's warm. See, we're about a 1 3/4 to 2 amps fluctuating. 260 volts. And the temperature is going up slowly. Steam is starting to come out. We're steaming the water in only a few seconds of action. And it sounds cool too. Here, get a closer sound of that. Kind of sounds like a Ferrari underwater, huh? That's cool.
All right, so I stopped it there. Everybody gets the idea. I don't know if you guys have any questions or if you want me to keep going, or if we should wrap it up for today, as everyone's looking pretty tired and it's been a long one, although I do have another segment of one of Jeremy Reese's videos, older videos. It's about 15 minutes long on cold fusion that gives pretty much the best history of it. Up to you, Jeremy, if you want me to play that to keep it going, or if you guys are tired and want to wrap it up.
You can go ahead and play it, man. We're just hanging out here. I got some friends here that from the conference. Met some new friends here. Contacts these two gentlemen. So they're super interested in cold fusion and some of this stuff as well.
Okay. First, then, if there's no questions, and before I play that, I'll.
Yeah, I have one question.
For sure.
How close do you think, would be that we have those devices in cold fusion commercial that you can use in a car, for example, electric car, like a Tesla car, instead of battery, that how close in the future?
If there was
the
100 million to $1 billion put in, you could have it working models within 2 years, mass production within 5, no problem.
Billions of dollars would it take to make it happen, or millions?
more millions if like to get working models, no problem.
Mhm.
And like that's what's so frustrating is that there's literally trillions being put into this hot fusion reactions, which in the tokamaks and whatnot, which are just ridiculous. Like they're insane because they require the amount, you have to create the entire amount of energy like in density of heat, pressure, electricity, and everything for the environment to then push and force two atoms together, that it's just so impractical and ridiculous that you're having to expend that much resources on creating the energy first, instead of these LENR reactions where it just takes the tiniest little vibration of energy, minuscule on the opposite end of the spectrum, to create these reactions, but that they're
It does it through entanglement, though. There's this hydroton model that they've come up with, and it's an extended Hamiltonian where whereby all the Hamiltonian functions, the potentials are all linked in a chain among all these coherent entangled deuterium atoms in the inside of this lattice. So you pack a bunch of deuterium atoms inside this palladium lattice, or platinum cathodes. Palladium cathodes work the best, I believe. And then when you get up to over a certain loading percentage, around 94%, I guess is like where it works the best. Anything above that or below that is not optimal. And then it also helps if you shine certain infrared lasers on them, or they use this super wave pattern where they actually got better results. So it has something to do with this extended. They haven't quite figured out the full physics of it yet. Hagelstein was working on that still like 10 years ago, and Edmund Storms, who has his whole theory that came up with that hydroton chain model of entanglement, whereby you're basically, instead of trying to brute force your way over that Coulomb barrier as in conventional hot fusion, you're actually tickling the dragon's tail, or tricking it through the Hamiltonian, which extends over this large potential chain distributed over several molecules. So when you get these waveforms, they can peak out and actually break that Coulomb barrier through tunneling. And that's what they believe occurs. There's evidence of it. I mean, it's been confirmed by NASA. It's been confirmed by the US Navy. It's real 100%. There's no denying it. And it's just a matter right now of building the technology to efficiently have fuel in, production out, but also you have degradation of the metal. These cracks and other things appear at the sites of where these EVOs form. And so you have cracking and depletion of the metal cathodes that you're using. So reached out to that researcher, Mitchell Schwartz from MIT, a couple of weeks ago, and asked him, for an update on his research. And he informed me that he had recently published a paper on using nitinol wire for the cathodes, because the memory, the shape retention alloy allows that for those active sites for the metal to repair itself. So we've essentially solved one of the major engineering hurdles of this. Now it's about designing the nitinol wire in a way that we can effectively use it for to build these cathodes. And I was just like, this memory foil that they talked about at Roswell, where it's this finely woven nano wires of nitinol wire in this mesh, might be the perfect candidate material for how to actually do this. And that might lead. So we have some insights now on this, and I've of course shared those and passed those along. But yeah, I think if we can get the right engineering and we have the material science to do that, probably off the shelf with a little bit of R&D. I think that, yeah, within 3 to 5 years with the right investment, we could have potentially working reactors if we could solve those the three main engineering problems. That's the depletion of the cathode, of the metal of the cathode, the issue of the fuel source. So you have to new deuterium in, and then byproducts out, so that it produces helium. So you need a way to dissipate that helium and get it out of the active sites. And so that, you know, you can get the waste materials out. As long as you can have an efficient process with that, and you need to be able to boil, and then as long as you can boil a cup of water, right? You can boil my cup of water to make me a cup of tea with your benchtop cold fusion device. You'll have enough proof of concept to bring to industry, and they'll fund it. Because that's essentially what you need. If you can boil water, you can make steam, and you can put a turbine on to make a power plant.
Right. And like, that's huge what you just described. And that's essentially the development and continuation of Pons and Fleischmann's original works in cold fusion discoveries out of Utah State, was it, or whatnot, in the late 80s, early 90s?
Provo, Utah. What's the college out there? Brigham, BYU. Yeah.
Yeah. See, and then another aspect of it that's not really discussed or talked about or incorporated is that there's also the possibility that we could have this heat coming out of it without it going all the way into helium, and then you're mass producing hydrogen as well out of this reaction, and then it's two birds with one stone if you're able to get the hydrogen fuel out of this process as well, and utilize the electrolysis at the most efficient input or minor electrical input in. And what I theorize is that it's the harmonic frequency, that if you can match the correct harmonic frequencies electrically and vibrationally through acoustic sound going in, that that should be able to then align the molecules along those crystalline chain lattices and mass produce the reactions, as opposed to just like small reactions happening with inefficient resonant energy going in, sort of thing.
Yeah, and some research would have to be done into that, you know, more tensite phase transition with the nitinol wire to make sure that, you know, you could have this above, you know, 212 degrees Fahrenheit, so you could boil water continuously without having it pass that phase transition, that transition temperature. So I don't know that this, I have to look into this, and there's a lot of research that needs to be done on it. But a lot of people missed that last thing because I was muted on my end for my live stream audience. But I just wanted to point out that my contact from MIT, Mitchell Schwartz, recently said that he's been working on using nitinol as a cathode in some of his experiments, and getting interesting results. As one of the problems with the engineering of these cathodes is the metal deterioration of the active sites. So anyways, Michael Boyd's here. I gotta go let him in. I'll be right back. You guys.
For sure. We love Mr. Boyd. He's a regular on both APEC and my own channel quite frequently. For a few minutes then, until Jeremy and Michael get back, I'm going to play a clip of myself, Bob Greenier, and Jeremiah that was recorded about a month and a half ago, where Bob goes into talking a bit of the LENR Evo stuff, as well as the new triple solenoid coil that he's been discovering, working on, and Jeremiah's replication of the same coil in it. If that is all right with everybody, if you're still hanging in there. Or do you have any other questions?
Right on there, it's a far one. You guys are over there. We're right here. Watch out.
Good stuff. Mr. Boyd is in the house.
Tour, as you called it, which is actually a fourth order tour, and a gorgeous one at that. And taking a look at this stuff. Okay, so we were just looking at these little spirals, and I'll give an instruction for anyone that wants to replicate one of these very terribly difficult to replicate things. Okay, this is one of those fiberglass rods from Home Depot, and these are used for snowplow trucks to identify where not to drive into. And anyways, you can stick this whole entire 4 or 5 foot length into a drill and start by spiraling your wire around this rod. And because this rod is fiberglass, And because copper is springy, which can be a bit of a problem, what I did is hook up both sides of each full length to a power supply and heated the wire up, not to the point of destroying the insulation, but we're only talking about, maybe running 20 or 30 volts here at 30 hertz according to the original paper, which is not going to be a problem even if the insulation was slightly damaged. But it's not. I got it to the point where it darkened, and what that did was anneal the copper just enough so that it didn't try to unspring or unwind itself when I pulled the whole thing off the rod. And because it still had just a bit of spring to it, it was very easy to remove. So I just took those in sections, and I'll show if I can. Yeah, so here's a section.
Can I step in there? Because that's a very valuable thing, what I think you've done there. But I think maybe, could there be a way where you could get one of these thermal tapes and put it around the point at which you're winding? And so you're just only applying the heat for the time it needs to do the winding, or just prior to it?
No, you couldn't, because you need to anneal the entirety of the copper loop. And if you try to heat this from the outside,
no,
or
I'm saying
with
you
a
do
torch
that,
or
but you
anything
do it
else,
as it's progressively winding.
Oh, I guess, yeah, you could.
So you're not
do it
continuously heating the whole wire. You're just doing it. You preheat it just before you go into winding, or just post heating it, like you do when you're perming someone's hair, right?
Yeah, that's actually a really good idea. If you wanted and did not have to, if you didn't have to rewind it at all or make any mistakes, and you didn't have to tighten it because it was a perfectly tight wind, or make any adjustments after putting your length on the rod, and you had already annealed it, then of course it would want to hold its shape because it's not going to want to unbend. But the trouble is that when you buy magnet wire, it's already gone through a multiple number of spoolers and rollers, and so it's going to have a bit of a memory to it, and we need to remove that first. Of course, we need to remove that without damaging the insulation, and I figured the best way to do that is actually from the inside out. So anyways, when you go to wind these things, after you get it on the rod, you take it, you take the long single coil off the rod, you wind these loops back around the rod, and what I ended up doing was just kind of running a whole long length of hot glue right down the side. Now, this is a terrible method. I would not recommend that people try this, because the hot glue, if it seeps in a little too deeply, or if you're off by, say you want to attach just 4 coils together, 5 coils together, 5 loops of each of these coils together, if it's a little too thick, it's not going to bend, and that's a major problem, so don't do that. What I would instead actually recommend doing is taking a long strip of, say, flexible tape of some kind and running a bead of silicone along it, and then setting this down into it and waiting for that silicone to cure. If you don't want to wait 24 hours for silicone to cure, then get yourself a 2-part silicone epoxy mix. It's not technically epoxy, but 2-part silicone, and that way you can get each of these rod lengths done in, say, 2 hours or less. And so I just wanted to point out the connection point here at the middle. Let me roll back around there, because for people wanting to replicate, this is kind of important, because you can only wind, say, 5 feet at a time. So there it is. There's just this little solder point where right in the middle of the loop, we make that splice, and for a full tour, we would actually need to make probably 3 or 4 splices all together, ending up with a total loop length like this of almost, well, for this size rod, I think this is like a 6 millimeter. So we'd probably end up with a whole loop length, if we just looked at something like this, of about maybe 10 foot long. And that of course adds its own complexities. But I wanted to ask you something specific, and I've been wanting to ask it since the day that you did the original broadcast, the one that you were so excited about before translation, APEC broadcast. And that part is the one that I think stands out the most. Not whether or not the field projection is strange or anything else like that, but the fact that you disconnect the signal generator, according to the author of that paper, and that a magnetic field probe, or a microtesla as they call it in that paper, picks up, feeding to an oscilloscope, a continuous signal for up to 2 days at the same frequency with the identical wavelength, slowly decaying in amplitude over 2 days. Here's what I wanted to ask you, but I had to premise, what we were talking about first, and we have to remember that the oscilloscope and the probe have an input impedance. That means there's a resistor in there of some kind, or some kind of resistance down the line. So in order for that probe head to do work, in order for that probe head to pick up a signal, it has to be doing work, which means the oscillating field stuck in space is actually generating a usable magnetic field. Yeah. As long as we don't swipe it out or knock it out with a spark discharge, we could be looking at a system that's upscalable, that generates a massively powerful and useful magnetic field, which continues to operate after only a small amount of input power and priming. 2 days, okay? So, that's what I wanted to ask you about, your thoughts on what could be do with that? And do you think that if we really tried to load that, or if we put an external field pickup coil around it, that we might destroy the cluster, or that we might destabilize the natural geometry that the evil is formed, or I should say the virtual evil, if that's even what it is?
So, firstly, I would say that what you're forcing nature to do is what it wants to do anyway, and so it's kind of like corralling a load of sheep into a pen, or schooling fish, like dolphins do. You can think of the coil, in my view. This is the way I visualize it. I'm thinking of the coil as like the team of dolphins, and they are getting the sardines to ball up. Okay, so that's kind of how I visualize it. And so what I'm trying to encourage is people to use natural things like plants, who want to do this anyway, to cohere this condensate from the cosmos, and you are encouraging that process to go on that already wants to happen in nature. And so David Boutillier is working on a system where he's making these coils. He's keeping it at the 3-level Tor, like it would look like you're doing with 3-level Tor, and that's the one that showed the effect. And that should show a magnetic persistent field, as claimed by Schwerblis' observation of the teams, but for the 3-level Tor.
That's the most exciting part about the whole thing. If we can prove that, and I love what Hank's doing, and I love what Cosmic Dave is doing. But
I'm talking about David Boutillier. David Boutillier is looking to. One of the suggestions is, or the first suggestion actually was, to try and make your ball lightning. So he's creating a plasma reactor and having the coil in there, and he will put the coil in clay and have cooling going through it, so that it doesn't get damaged. But that might encourage self-clustering of the plasma. So this, for me, is a very, very exciting prospect, because when we already know ball lightning can consume matter, and in the process of consuming it, it's actually doing this self-organization anyway. But if we have a precise way where we can force the ball lightning to be produced out on demand in a particular location, then ball lightning can spin at hundreds of thousands of the matter around the ball lightning, like the charged particles. They can spin at hundreds of thousands of kilometers per second. And so you can then have a pickup coil, which may actually be the coil that you use to form it. It may play 2 roles, and then get induction back. In the case of Solin, in his 2001 patent, he created the coherent matter, which span, and then he had a single cooled induction coil to harness the direct electricity that would be generated from that effect. So, but of course, Solin used an electron beam furnace, which was it's a very large device. It's a commercial device for melting metals that are very high.
All right, I'm gonna pause it there as it's getting pretty late. Jeremy, Mike, Mark, you guys got anything else to say? Any questions?
Yeah, Mark is not here right now. He went out to back out to the other conference, that's still going on here in the other room. But Michael Boyd just joined us and came in. Yeah, so
hello, Mr. Boyd.
Hey,
how are you, my friend?
I'm good. I just heard he was here, figured I'd go over the hill. I used to live about 1.5 miles from here, where we're at. So
well, that's awesome.
But now,
so jealous I'm not there. Maybe by next year. Hopefully by next year.
You couldn't drive down from Vancouver, huh?
Well, Alberta, Calgary, Alberta.
All the way out in Sasquatch town.
Yeah. Hopefully by next year I'll have figured out how to produce some hydrogen within like a working engine within my vehicle that then I'll be able to afford to drive across.
So we got the Sasquatches around here too. There's actually in Felton, California, there's a Bigfoot museum.
No.
I have pretty big feet.
Right?
My son is definitely Bigfoot. He's got like 14-inch foot. So yeah, Cool, dude. And I'm glad you got your own spot there on APEC. That's pretty awesome, dude. I was kind of excited
Thank you.
when I heard that.
I appreciate it. So, yeah, everybody looks a
Don't
little
blow
tired.
yourself
It's
up,
probably
okay?
7 or 8 hours now, so we should probably wrap it up, and I'll have more together for next month.
Heck yeah.
Thanks everybody. That was great, and that was awesome, especially with the guy earlier. That was really cool. Thanks a lot.
Appreciate it, Philip.
Yeah, man.